We're sponsored today by Forward Networks. Enterprises rely on Forward Networks' network digital twin for unified, trusted automation across distributed hybrid networks. Forward Networks' network digital twin ensures connectivity isn't disrupted, security posture is unchanged, and compliance is maintained at all stages of change management. Forward Networks' digital twin is the difference between risky automation and operational certainty. Learn more about how to protect your network and your sanity with Forward Networks at forwardnetworks.com/packetpushers.
Hey, everybody, and welcome to this episode of Packet Protector, the podcast at the intersection of networking and security. I'm Jennifer J.J. Manella, here with our co-host Drew Conry Murray, and we're talking certificates again. We think that certificates are like the socks of IT. Everybody needs them, and you always lose track of a few. I don't know, maybe that's just me.
I love that.
Anybody listening who's managed certs in enterprise, I think you know it sucks. And I bet we've all woken up to some service or website or app that suddenly stopped working overnight because we missed renewing one. I used to track them on my calendar. I had some in spreadsheets. It's always a very unelegant mess, especially with the certificate validations shrinking. And we're talking, orders of days coming in the future. So that's where ACME and Let's Encrypt comes in. So automating the whole messy process of getting and renewing certs so that we don't have to play calendar roulette. And our guest today is Ed Harmoush, former network engineer with AWS and Rackspace, and the creator of practicalnetworking.net. You heard him on episode 45 back in January when we started our certificate conversations at the request of some of the listeners. And he's back today to demystify ACME and how certificate automation can save our sanity.
Yeah, he gets into a step-by-step discussion of how the ACME protocol works. It is an IETF standard, so this is widely used. We talk about ACME clients, ACME servers, and again, he walks step-by-step through the whole process. So if you are dealing with certificates, certificate validation, and you want a better way to automate it, take a listen to this podcast. So Ed, welcome back to the podcast. We're delighted to have you back. And let's start with a basic overview. What is Let's Encrypt for those not familiar with it?
Oh, thank you so much for the invite back. It's an honor to be here. So Let's Encrypt is a certificate authority that started back in about 2015 or so. It started with the purpose of issuing free certificates in a fully automated way. So back then, they weren't actually the first certificate authority that was offering free certificates, but they're the first one to do it purely, entirely based upon automation. The initial version of Let's Encrypt was using the first version of the ACME protocol, or rather, what they did for automation is what turned into the ACME that we use today.
Mm-hmm. Should I be worried that it's a free service? Because usually when you consume free services on the internet, it's because you are the product or you are being exploited in some way or information is being collected or whatever. Is that an issue with Let's Encrypt or?
Yeah, that's a totally fair question. In this case, it's not. Their main goal was not to collect information or data or anything like that. Their main goal was just to secure the web. Their stated mission statement was literally just let's get the entire web secure. And they actually contributed a large part. If you look at like percent of websites that have HTTPS enabled, there's a large spike that happened right after 2015, right after they kind of came back around. Mm-hmm. There's a lot of value to get automated certs for free for any website you wanted. And we do want a secure web. So they're pretty key in enabling that.
And how would you compare Let's Encrypt to other CAs? Because as you mentioned, it's not the only CA available.
Yeah, absolutely. So the main thing is they do the free DV only. So DV stands for domain validation certificates. And that gets into the different types or classes of certificates. There's 3 of them, and each of those effectively reflect how much work you have to do to prove that you own a particular domain. Mm-hmm. So with Let's Encrypt, they only offer DV certificates. The other 2 types of certificates that exist are OV, organizational validation certificates, and EV, extended validation certificates. The OV certificates not only verify that you own a domain, but also verify that you are an actual company. They verify company filing records and stuff like that. And then the EV certificates go one step further. They verify you've been in business for X amount of years. They verify a physical address, and they make sure that's linked to the certificate and so on. The thought initially between the 3 types of certificates was that it's more secure to have an EV or an extended validation certificate. But currently, probably I'd say since like early or maybe late 2010s, the significance of that has kind of gone away. Most of the time, rather in the current world, DV certificate is looked at as completely good enough. And as a comparison point for that, it's something like a passport versus a driver's license. A passport certainly takes more effort to acquire and involves more verification for you to get. But at the same time, if all you're doing is trying to verify that, say, I am really Ed, whether I give you a driver's license or a passport, you'll be happy with that. So there isn't really a need necessarily for the purpose of identifying if you own a domain to go to extended validation. So currently, EV and OV have somewhat fallen out of favor, and DV, or domain validation certificates, are looked at as completely good enough for the modern age. And part of why Let's Encrypt only offers those is because it's the only one you can do in an automated system.
I'm not going to take us down this rabbit hole, but there's a little piece of my brain wondering if, all of the malware and ransomware gangs that are out there and the people that are putting up, phishing sites and stuff, if OV and EV, if that level of validation to ensure that an organization is actually, a legal entity registered somewhere would be some easy bar of filtering out certain websites for purposes. But that's a whole different can of worms in a conversation, but I'm going to tuck that away for later.
That's totally a fair point, but I'll quickly say the big thing that EV and OV required was for the user to recognize. And so initially they would add an additional, I don't know if you guys remember back when the browser bar would turn green, or there'd be additional green box in the browser box. And so the thought was oh, if the user sees that, they'll be okay, I can trust this more. But it turns out most users completely ignored that, and there wasn't really an actual benefit to it. And we don't really want to create a world where we have to have the user make a decision, right? We want to create a world that is just safe no matter what.
Right.
And the user almost, it's almost like magic. It doesn't have to think about it, if you will.
All right, so the main thrust of our conversation today is the ACME protocol, and ACME stands for Automatic Certificate Management Environment. Let's Encrypt uses the ACME protocol. It's an IETF standard, and I understand that ACME was developed to automate as much as possible the process for a domain owner to get a cert from a CA, and it's validating that the requester controls a web server's domain name. Did I miss anything about ACME?
No, that's spot on. So it is fully automated. It allows you to acquire a certificate without any actual, we'll say, contact, or phone call, or anything like that with the CAs. You can do it purely from the CLI using a bunch of different tools and scripts and stuff like that. It also includes fully automated renewals, depending on what software you use and what flags you use on the software. Yeah, and it's not just used by Let's Encrypt. So they created ACME version 1, and only they used it back in 2015 or so.
Mm-hmm.
But in 2018, they publicized, or rather, they were involved in the development of ACME version 2, which is what the entire world uses now. And a bunch of different certificate authorities now use ACME version 2, the one that exists in the RFC. And it's RFC 8555, if you want to look up the details of it.
Okay, and Let's Encrypt has also moved over to ACME 2?
Correct, yeah, absolutely. The main benefit to creating a public standard like this is prior to ACME as we know it, or ACME version 2, a lot of other CAs also had automated ways of issuing certificates and whatnot, but every CA had their own API language, had their own API calls, had their own systems, their own implementation of how they do that automation. And so you would run into issues of, say, vendor lock-in, where if you're stuck with a particular CA and you've built all of your automation around that CA, you can essentially never change because that's the only CA who you've built your software around. But the benefit of something like ACME is that it's something all CAs can implement, and most CAs presently that have automation enabled do it with ACME. It is the current default across the board. To switch to a different CA, it's just a different command. It's just a different flag or different config file. So you can very easily get certificates for multiple CAs, or switch to a different CAs without redoing your entire automation infrastructure and programming and whatnot.
So how does it work? So first of all, I didn't realize that they had started the version of this automation, back at the genesis of Let's Encrypt that far ago. But I think most of us are, the manual process of requesting, certificates and generating CSRs. So what are the steps in this, and how does it connect it into the various infrastructures that are using it?
So we're going to spend some time here. There's a lot to it. So for the sake of terminology, let's start with this. So I'm going to use the term ACME client a lot. And what I mean by this is the system or the software that is initiating a request for a certificate. So ACME itself is just a language. It's a protocol. It includes a bunch of commands or calls that we're going to talk through in a minute, but there's a bunch of different software that implements that protocol. This would be something like, say, FTP, or file transfer protocol, involves a GET request to download a file, or a list request to list the contents of the directory. And there's a bunch of software that implements FTP, like FileZilla, like Windows Explorer, like most browsers, and so on. So the ACME client is what I'm going to say is the generic entity that represents whatever software is making these requests. Now, some common ACME clients that exist out there are certbot, probably the most commonly known. There's also acme.sh. That's the one that I'm most familiar with. That's one that I use for my various websites. And it's just a bash script that implements the ACME language, if you will. But there's a bunch of others that exist. There's one called Caddy. There's one called WinACME for Windows-based environments. And there's probably a dozen or more that also exist. And all they do is implement the ACME language, if you will, or speak ACME. So ACME client is the thing that's initiating the request for a certificate or renewal, revocation, and so on. And the ACME server is going to be generally the CA. So the CA that's receiving these requests and giving out certificates and so on.
And is the client something that's embedded in whatever's actually needing the certificate, or is it something just sort of external that makes the request on behalf of?
Either. It can be either.
Okay.
So in the simplest of environments, if you just have a simple web server, say a Linux server running Apache or something like that, if you don't already have ACME installed by default, which a lot of Linux distributions does, it's available via simple like yum install, apt-get install. Like it's free, it's available very, very easily. And you can download the software, initiate from that server itself. And then your web server will now act as the ACME client, making requests to the CA to download certificates or acquire certificates. You can do it in a way where it's not necessarily your web server that is doing the ACME client roles. That limits the types of validations that you can do, and we'll get into the details of that shortly. But the easiest way is to have it so that your actual web server itself is also running the ACME client software.
Okay. And as you mentioned, there's a variety of choices, and we'll get some links in the show notes to those.
Yeah, absolutely. Okay, so let's talk through the flow, the sequence of events that happen. So in general, if we step aside from ACME, right, the way the SSL essentially infrastructure works is you buy a domain, you send a CSR to a certificate authority. The CSR is a certificate signee request. It's essentially a piece of file that says, this is my domain, this is who I am, please give me a certificate. The CA gets it, the CA verifies the information, validates you own the domain, and then gives you a real certificate. So that is kind of the overarching process that ACME is going to automate. It's going to do magically behind the scenes, if you will. So look for those steps to happen as I'm going through the process of ACME.
Okay.
Okay, so the first step, brand new, right, is the ACME client is going to do what's called a directory request. This is where the ACME client is going to send an initial request to an ACME server, effectively asking, what features do you support? So ACME itself can do a bunch of different things, and not every CA might support every single one of those features. Moreover, ACME, the RFC, has some like recommended API URLs that they recommend to use, but those aren't mandated. There might be CAs out there that use different or variations of the API language itself. So the way the ACME client discovers all that is by doing a directory listing request. And essentially, this is the client saying, hey, I'm reaching out to you. The URL, the initial directory request is going to be published by the CA. So the CA is like, this is my ACME endpoint. This is where you start your directory request. And this is where the ACME client will learn what the ACME server supports insofar as ACME. That request is unsigned. It's not secure. It's essentially pure read-only. There's nothing we have to protect in that sense. So that's just a generic request made to receive the features that this guy supports.
And that's sort of typical for a protocol where you've got a client and a server connecting and exchanging sort of, what are our capabilities? What can we each do?
You could almost make a correlation that this is almost like the three-way handshake of a TCP connection. It's almost like, hey, we're about to start talking.
Yep.
And then there's one more thing that also involves what would be like a TCP connection, but we'll get to that in a second. So that's the initial contact. So the ACME server is going to respond with a URL for one of 5 different features, essentially, that the CA ACME server can support. I'm going to step through each of them, but just to list them all out now, those 5 are the new nonce request, the create new account request, the create new order request, the revoke certificate request, and then the key change or key rotation request. These 5 are effectively the 5 core operations that ACME supports. There are other calls that will exist, but insofar as core operations, those are the 5 that exist. And some of those will prompt additional further URLs and calls that'll exist, but those are the 5 main ones. Starting with the new nonce request. So when doing this communication with the CA, they wanted to find a way to secure that communication. And by secure, I mean essentially, well, in this particular context, I mean avoid replay attacks. If you're asking for a certificate or trying to revoke a certificate, you don't want someone to be able to capture that packet and replay that later on.
Okay.
And the mechanism they used for anti-replay is essentially to use a nonce tied to every single request that's built into the signature of the request itself. And nonce, so it's a cryptography term. It stands for number used once. And all it is an arbitrary random string that is meant to be embedded in every single subsequent request. Well, if you've never talked to the CA before, you need to start off with an initial nonce. And this first nonce request is how you get this. Every ensuing request you made is going to include a new nonce by itself. So that's how continued anti-replay works. But to kind of kick off or prime the sequence, there's this initial new nonce request that doesn't do anything or change anything. The request itself isn't secure or signed. It's just saying, hey, I need a nonce to kick off a bunch of real requests that are going to do actual work in the certificate lifecycle world.
It's just a unique identifier to tie it to that string of requests so that that can't be used again. And I guess it tie it to that time as well.
Correct, yeah. And so the initial one, let's just say the first one you get is nonce1. Your next request, which would be, say, creating a new account or something like that, is going to include nonce1 in there. And then when the server responds, it's going to include yet another nonce, maybe nonce2. And then your next request will then include nonce2 and so on. It's something like a sequence number, but it's not actually sequential. It's all kind of arbitrary and yeah.
It wouldn't be a valid signature, essentially, if you could just increment it by one if you knew the sequence of numbers.
Right, 100%. It essentially makes sure that the conversation is always like a one-to-one request response that can never be replayed maliciously in the future.
And is this happening because as of this point, we haven't set up an encrypted communication between the client and the server, that we need to use this nonce mechanism?
Correct. These requests are made over SSL, over TLS, so that does exist. But we don't want, if you have parallel computing or multiple things making the request, we want to make sure that every flow is sequential and not repeated in any way.
Okay. So step one was the nonce.
Correct, yeah. So step one is asking for a nonce. And again, that's just to prime the sequence. Every other nonce you get will be built into every response you get. And so that's how you continue nonces. Okay, so that's one of the 5 core. The second core operation of ACME is the account creation request. So here you make a request to the ACME server. You say, hey, I'm creating a new account. And the account is just for the purpose of categorizing all the certificates that you yourself request. So it isn't going to turn into, say, an account you can use like a username and password that you can log into like Let's Encrypt web portal or something like that. It's purely going to be just for the automation to categorize all the requests that you make. So if you are doing this on behalf of a company, you should have an account for that company. I myself, for my certificates and stuff like that, I have my account based upon my email address itself. The email address is never used for any sort of marketing. It's just kind of there for certificate management, if you will. You can actually do this even without an email address if you want to do this completely anonymous. But what this does essentially gives you an account number that categorizes all the certificates you request.
Okay.
You include in this new account request a public key, and you sign this account request with your private key. And so every account also is associated to one set of public and private keys. And then everything that you send going further tied to this particular account will be signed with that same private key. So the way you tell the ACME server, hey, this is my key set, this is my key pair, is this new account request that you made.
So we have certificates to get certificates.
Well, almost. So this is just the key itself, not a certificate by itself.
Okay.
Yeah, it's like certificate inception to some degree.
You did bring up something that I had a question about, which was, do I need to have my public-private key pair before I start this whole process? I've got to go get that before I can start doing any of this ACME stuff.
So yes. So let me backtrack a little bit. Creating a public and private key is very easy. In fact, on a Linux box, if anybody has access to Linux box, all you have to do is type 2 words, OpenSSL gen RSA. Boom, it'll create a public and private key.
Okay.
Obviously, there's additional flags. You can tweak that to make it bigger, smaller, whatever. But creating a public and private key is very easy. Anybody can do this. When you're using ACME, all of the software that you use does this automatically in the built-in. So it isn't necessarily a separate step you have to keep track of. In the ACME, for instance, I use acme.sh, and the command in acme.sh to create a new account automatically also creates a public and private key for me.
Okay. So the client is doing that in the background for me, essentially.
Yeah, absolutely. And I'll also quickly mention, this is just a public and private key, not a certificate that also associates an identity to that public and private key. Well, really, it's just one private key file that includes both the public and private key.
Got it. Okay.
And there is no verification at this point. So all you're doing is telling the CA, hey, I'm creating a new account. This is my public key. And the CA is like, okay, great. Now I have your public key. Obviously, it'll verify the signature, but there isn't like an association of like this key belongs to Drew or JJ or Eddie or whatever the case. All right, so that is the second core operation. So we talked about the new nonce, that's the first. The second was the account creation. And then the third, and probably the most important, is the new order request. This is where I'm actually making a request for a formal certificate. This request involves a few things. The main thing you're providing in this request is the domain or domains that you are meaning for this certificate to protect. So side quest for a minute, certificates themselves traditionally only protected one domain. but things like SAN or subject alternative names were added as an extension to certificates so that a single certificate can protect multiple domains. And most simplistically, you'll see this like if I had the site site.com, I could have one certificate validate the identity of site.com, but also www.site.com, or also mail.site.com, or something like that, or images.site.com, and so on. Yeah, so your first request, the new order request, is going to include, the most important part probably, is all the domains that you want this particular certificate to protect. You can do, like I just mentioned, static domains like www.site.com, site.com itself, but you can also do wildcard. I can say star.site.com, and this will protect anything.site.com for this particular request. Some CAs also let you specify attributes of the certificate, things like the validity dates and whatnot. But a lot of CAs also override that based upon their own policy and standard CAB form, best practice, and stuff like that. In response, the CA is going to send back what's called an authorization URL for every domain that you made a request for. So what's meant to happen is for every domain that you make a request for, you're also going to have to prove that you own that domain. So if I want a certificate that protects site.com and www.site.com, I'm going to get two authorization URLs back, and both of those are going to be the start of the validation process to prove that I own both of those domains.
Can you talk a little bit about how that validation process works?
Absolutely.
Yeah, like how automated is this? I'm really interested.
It's amazing. So the first time I used ACME SH, I ran the command, and it was simple like, what's the command to get a certificate? I got the command, I typed it in, hit enter, and magically I had a certificate a few minutes later. It's incredible. Okay, so remember we were doing domain validation certificates, and to do that, all we have to do is prove we own a domain. There's effectively two ways that are used most commonly. There's a few others, but these are the main ones that you'd want to focus on. There's what's called an HTTP validation and a DNS validation. And if you look into the RFC itself, these are labeled as HTTP 01 and DNS 01. And the thought there is if we think of a better way of doing it in the future, we might create an HTTP 02 or HTTP 03 and so on. For the current world, the 01 versions are all that exist. So if I say DNS validation or HTTP validation, I'm referring to the 01 version. So the HTTP validation works like this. What'll happen is the CA will give you a token, and the token is just a random string, just a random set of letters, and they'll expect you to publish that token at a particular website available over HTTP. So if I buy the domain site.com, I make a request to the CA. I'm like, hey, I own site.com. The CA is going to give me this string and say something like, publish this at the URL site.com.wellknown/acme challenge/ here's the token, right? And if I actually own the domain, I can do that. I can take the string that they gave me, put it up on my web server so that it can be accessed over HTTP. The CA would then, after giving me the token, start periodically checking to see if that becomes available. And if it does become available, it then proves that I must own the domain. By comparison, if I was, say, trying to maliciously acquire the domain, a certificate for google.com, I can make the request, right? They'll give me a token, but I have no way of publishing something at the URL google.com/acme challenge/token or whatever the case, because I obviously don't own google.com. So that is how they can use HTTP to verify that I own a particular domain.
And it sounds like you'd have to do that for each of the
Correct.
domains or subdomains that you've requested. Now, if you do it from the DNS, can you do it all in one swipe? Can you kill all those birds with one stone?
They'll expect a different token for every domain that you request. And they're doing this just for the sake of thoroughness. So the DNS validation works a little bit different. So in the DNS validation, again, we're just trying to prove that I own a domain. So say I buy the domain site.com. I ask the CA, hey, I want a certificate. They'll again give me a token, but they'll also give me instructions to publish this token at a particular text record available online. This text record will include the token, and then the CA can pull for that DNS record to kind of validate that it worked out. If I own site.com, I can publish DNS records for site.com, but since I don't own, say, google.com, I can't modify the DNS records for google.com, and this is what protects me from getting a certificate for a domain that I don't own.
Can you, as a requester, select which method you want?
Correct. So in the new order request, I say I'm willing to do these authorization methods. And then you can even do both. You can say I'm willing to do HTTP and DNS for either of these. And then the CA will give you a token for each of those, but only one needs to come through for the CA to be like, okay, sweet, you actually own that DNS. You don't have to double verify you own a domain, right? One is enough, if you will.
Okay, so you don't get any benefit of doing a double validation that you own the domain.
No,
You're
no.
super validated.
you doubly own this domain.
But I did want to poke into the DNS a little bit. So I guess my question is you mentioned like site.com
Mhm.
and then www.site.com. So if you had site.com, www.ed.site.com, everything on the same TLD, can you validate that with a single DNS token in the text record, or do you have to still do that per subsite or per prefix?
It'll be per. The token itself will have the domain name you're being requested embedded into it. So if you request 5 different domains, there'll be 5 different tokens that you'll have to publish. And so in the case of DNS, you can have unlimited text records published to a particular domain.
Let's pause for a word from sponsor Forward Networks. Forward Networks creates a digital twin of your network. Enterprises rely on Forward Networks for unified, trusted automation across distributed hybrid networks. Now, if you think a digital twin is just a network map or an inventory list, think again. Forward Networks' digital twin is a mathematically precise digital replica able to model all config and state data on every device and trace every possible packet path. With Forward Networks' digital twin, you can ensure that connectivity isn't disrupted, that security posture is unchanged, and compliance is maintained at all stages of change management. That's why enterprises rely on Forward Networks for unified, trusted automation across distributed hybrid networks. With Forward Networks' digital twin, you can eliminate change-related outages and the subsequent headlines. That's why Forward Networks' digital twin is the difference between risky automation and operational certainty. Learn more about how to protect your network and your sanity with Forward Networks. Just go to forwardnetworks.com/packetpushers. That's forwardnetworks.com/packetpushers. And now back to the podcast.
Do those stay there? Because I feel like any of us that do any type of work with integration and proving domain ownership, we have all of these silly DNS text records where we're, various validation for whether it's Microsoft or Google or, fill in the blank service that you're integrating with your domain. Are those intended to persist, or can we tear those down later?
Once they're no longer necessary, once the domain is validated, they don't need to stay, but they're harmless if left up. Again, the contents of the token is arbitrary and completely insensitive, if you will.
Yes.
The most that someone could glean is knowing, oh, you're using DNS automation to verify your certificates, or even possibly you're using ACME to get your certificates. But that itself doesn't really give all that much away.
Okay, so it's not a risk to have those records up or that HTTP URL up.
Correct.
No, it's just a lot of mess and junk after a few years.
Triggering JJ's.
Yeah, I'm OCD a little bit. I have OCD tendencies. So, all right. That's the fourth step, then the authorization and then the validation.
Correct. Yeah. So what happens is you do the new order, which includes the domains you want validated and specifies the type of validation you're willing to do. The CA will respond with a bunch of authorization URLs, one for each of those domains. And those authorization URLs are where you kick off the actual validation process. So what you do is you send another API call to the authorization URL. This is what's going to get you the actual token and what's called a challenge URL. And the challenge URL is what you would send an API call to in order to tell the CA that you have published the token and they can start their validation process. So what happens is you do the new order, you submit the domains, they give you authorization URLs. You make an API call to the authorization URLs to get the token. You then publish the token either on the web or the DNS record or whatever. And then you issue an API call to the challenge URLs to tell the CA, hey, start checking for this particular domain.
And when you say you do this, is the client doing it for me, or do I actually have to kick off an API request?
Yeah, entirely dependent upon which client you're using. Generally, the client is going to do it for you.
Okay.
So when for instance, with acme.sh, I actually saw the logs and the script running. So I hit the new order command, hit enter. And the cool thing about, in this case, acme.sh, it actually knows the web root of the domain that you're making the request for and will automatically get the token and then actually add the file to the web root directory of your, say, Apache server or something like that. So it was entirely automated. I didn't have to do anything. You didn't have to mess around with HTML. Right, exactly. I was really impressed actually at how it did that. The DNS one is a little bit different because generally you don't control the actual DNS server itself. You're not running like the Bind9 software like you might be running Apache or something like that. So with DNS automation, it does depend upon your DNS provider also having some sort of API call that can be used to publish a record and remove a record and so on. So not all DNS hosts do support that compared to if you're running it on the Apache server itself that's hosting your website. it knows the Apache root directory and whatnot.
Okay.
Cool. All right. So yeah, so the third core operation is the new order, which gets you the authorization URLs for every domain, which gets you the tokens and gets you the challenge URLs to tell the CA you've implemented the token as requested. The CA then does its validation, downloads the token, make sure it matches and all that fun stuff. If it does, rather, that process doesn't involve a notification. Essentially, what you can do is send the same API call, the same new order request. That's going to include a status. And when that status goes to valid, that tells you that all of the validations have already happened. And now you can make a request to what's called a finalization URL, which is only included as a response to the new order request if everything has been validated. And that finalization URL is where you actually send the CSR itself. So remember way in the beginning, before I kicked off all this, I said that the process of SSL hasn't changed. You still have to submit a CSR. Well, this is the step that you would do it. You get this finalization URL only after you've proved to the CA that you own all the domains. And that's where you send the actual CSR file itself.
Ah, so the CA isn't even entertaining your CSR until you've proven that you own the domain.
Correct. Absolutely. So for instance, a certificate can have a domain listed in the SAN entries or a domain listed in the what's called the subject field of the certificate. And how you specify that to the CA is in the CSR itself. This authorization step that we just went through is purely based upon here's domains that I want to prove that I own. And then once you've proven that, you can then issue a CSR that includes all the maybe certificate details that you can include in the final certificate, or rather you're requesting to be included in the certificate you request. Yeah, and so when you do that final CSR push, the response to that will be a URL where the certificate URL, and then you can do another API call to the certificate URL to actually download the certificate itself. Yeah, and so that's that whole sequence of events is the third core operation. So it all kicked off with that new order request, but included a bunch of kind of additional API calls that went based upon URLs that were given in those responses from there.
So now we're on to step 4.
Now we're on to step 4. Now, most of us will only really do 1 through 3. Step 4, hopefully no one ever has to do, but if you do, that's the revocation API call. And it's just an API call that you use to revoke a particular certificate. You sign that request with either the certificate's private key itself, or if you recall back when we created the account, we said that this account owns these public and private keys. So you can also sign that request with the account's private key itself.
Okay.
And that's pretty simple. It's just a request that's made. The certificate becomes revoked. Well, becomes revoked right away, but then the CA has to update its OCSB or its CRL to indicate that that certificate is revoked.
Okay. And step 5?
And step 5, the final one, is the key rotation. So if you need to rotate your account key, essentially replace it with a new set of asymmetric keys, you would use the key change API call. And that's a very simple make a request to the particular API endpoint. It involves including a signature from both the old key and the new key to prove you actually own those keys. And you would use that if you need to rotate your asymmetric keys with the CA.
Got it. Okay, so you anticipated one of our questions. We can use ACME to either revoke or update our domain validation certs.
Yep. You can use it for the entire certificate lifecycle, if you will. ACME has been built out to fulfill that, if you will.
Okay. So step 1 through 3, where I'm trying to actually just get my domain validation cert up and running, do you have a sense of, kind of the average time it takes?
Minutes.
Minutes, okay.
Yeah. Before this podcast, I set up a bunch of staging domains just to play with ACME and become more familiar with acme.sh in particular. It literally is just minutes. The account creation is pretty much instant because there's not any validation that has to happen. You just give it the public keys, you say, this is my account, and it's done. That's effectively instant. And then the new order, literally, I think most of the domains that I made the request was minutes. That's because acme.sh automated everything. It made the initial request. It received the tokens. It knew where my Apache web root server was. It added the tokens at the appropriate places. It told the CA that's been added. It waited for the CA. You actually saw it spin. It was like, waiting, trying again for 10 seconds, trying again for 10 seconds, essentially double checking the status of the CA's validation of the token. And literally all minutes. And all of a sudden I had a website available over HTTPS. I was surprised at how thorough and quick it all was.
That's cool.
So this is all the nice nitty gritty stuff. But I think if we back up a little bit, we're looking at why do we have to automate certificates at this point? And, some of the answer to that has been the validation periods are shrinking. We're down to, 90 days in some cases, are heading that way. I don't work in this world, but I know some CISOs and architects that do. And some of the things I hear are, okay, well, sometimes we're spinning up, web instances, kind of like microservices, and their lifetimes are measured in seconds, minutes, maybe hours. And so we have this kind of churn of resources and websites and URLs that to me is just not something I've had to deal with. And then we have the validation shrinking. Can we talk about like what's driving that and where we're going with things? And is this a good thing? Is this a bad thing?
Certificates have existed for a long, long time. And I don't know if there's an engineer that hasn't at one point been frustrated by the certificate world, if you will. All the way from like, what's the right set of commands and arguments you use with OpenSL to generate a CSR? What are the right rules that I have to follow and standards to make the CSR? And what do I need to include in the CSR? What's the incantation that's needed to actually sign the CSR, acquire a certificate, all that fun stuff. And every shop has a different, we'll say, structure for how they manage that. Like one of them, it's like for every domain they own, there's like an Excel spreadsheet that exists somewhere on someone's box that has like the dates for when they expire, and that's updated manually. Another one, it's like you generate a certificate and you create an event in your calendar for 1 year later for when it's going to expire. And then 1 year later, you're like, crap, what was the commands that I used? And all of this was just like this huge headache that everybody did different. And so the first big win that automation does is what I'm going to call standardization, right? Now there's a unified set of commands that exist to generate and issue a request for a certificate, right? This would be almost like all of us trying to create our own FTP, right? It's nice that FTP exists, but what if every single company had like, oh, let's create a new command language to download files from remote servers and so on, or whatever, right? So the first major win for ACME is standardization. And as we alluded to before, it's standardization that applies to all CAs, which is great to avoid vendor lock-in and whatnot.
Mm-hmm.
The other, and this is what JJ was alluding to a second ago, has to do with life cycles of different things. In the past, before automation, if I stood up a web server, right, it might be anywhere from 1 to 3 weeks before I can get a certificate and actually make that accessible securely, if you will.
Mm-hmm.
Well, with automation, it's, as we just mentioned, literally on the scale of minutes. So I can publish a new web portal, web app, web tool, whatever, and right away acquire certificates that can be accessed securely, which doesn't create this delta for when programming or creates a system and it can be used, this arbitrary delta tied to the certificate and not, say, the functionality of the web app itself.
Mm-hmm.
Moreover, going back to life cycles, the certificate validity dates is essentially they've set dates for the reduction of those pretty aggressively. So as of right now, you can't get a certificate that lasts more than about a year. I think it's 390 days, something like that.
Mm-hmm.
But they've set a date for March 2026. Certificate lifetimes are going to be capped to 200 days, right? And then they've set another date a year after that certificates will only last 100 days. And then 2 years after that, March 2029, they've said that certificates can only be valid for 47 days, essentially a month with additional kind of overlap time of acquiring the new certificate and whatnot. They haven't set a date for it yet, but they're trying to get it to where certificates only last 10 days. So that might be a 2030 thing when that actually goes. Which is crazy, right? For those of us who've had to struggle with like renewing a certificate using weird commands and like before automation exists, like that's like, wow, you need to hire 3 people just to manage all the certificates for your domain if they're expiring every 10 days.
Oh, yeah. I mean, the spreadsheets and the calendars are no joke. Now, I'm lazy enough that I put the exact steps in my calendar invite so that I knew next year what the crap to do the next time.
Right. I love it.
After I struggled through it year 1, but then of course, inevitably something changes and you've got to struggle through parts of it again. But yeah, I mean, it's bad enough when you've got just a handful of things that expire, once a year that you have to renew. And it's, everything has certificates now.
Absolutely. Even if you have all the commands year to year, it's still a human typing those commands in, right? And so typos could exist and all sorts of stuff, right? Whereas with automation, it's a computer doing it. And the computer's never going to make typos so long as you set it up to begin with.
That brought me to one of my other questions, which is, when I first heard about, ACME, which frankly was relatively recently, one of my questions was, okay, I understand it's for, the domain validation for doing TLS search on public websites, blah, blah, blah. But why aren't we using this for everything else? Because we do have certificates for, in the networking world and even in cloud infrastructures, we've got, certificates for, physical equipment, firewall, switches, routers, everything inside of the organization, in addition to, our MDM applications and all of these other use cases. And, it seems like it would be a nice step to get to the point where we could have some type of automation. Now, in hearing you describe in detail the flow, I understand why we can't, come out of the gate using it for everything right now, because that flow doesn't work for everything. But do you see a future where we're going to have automation for all of the certificates instead of just the ones for these websites?
Absolutely. And I think the big win will be because you can do wildcard certificates with ACME. So let's say I was trying to issue certificates to identify laptops that are issued by a particular organization, right? Like these are like tied to the hardware itself, right? And let's say these expire on a 10-day notice, right? And so the certificate itself is going to have some domain name associated to it, something like laptop01.mycompany.com or something like that, right? Well, if I can get a wildcard certificate if I can use DNS to acquire a wildcard certificate for star.mycompany.com, now I can acquire certificates for any domain, laptop 01, laptop 02, laptop 03, and so on, .mycompany.com. All I have to do is be able to set up the initial DNS validation at one time. So definitely the initial intent with ACME would be just websites. And that's the simplest and probably the 90% use case if we can automate that away. But you could use it for things beyond just websites as well with some amount of creativity.
As a security person, I have to interject that I think we'd have to figure out how to not use wildcards, just because, if you're using the wildcard for everything at, site.com in its laptops and its infrastructure and its services and servers, that's obviously not ideal from a security perspective. And you're going to get your hand slapped 20 times over from any auditor that comes in. But maybe there's an opportunity for something incremental starting with that in subsets of the environments. But, it seems like we've just got to get to a place where we can do individual device certificates a little bit. I mean, we have protocols for laptops and endpoint devices, but I'm kind of thinking about all the other weird stuff we've got floating around. Maybe that just takes more time.
Certainly. And remember, you can use ACME. There's ACME server software that you can use as well for internal CAs. And at that point, you can set up all sorts of different ways for how to prove ownership of a particular domain, or in this case, URI indicating a particular resource. So once you're controlling the ACME server itself, once you're using your own internal CA, you can set whatever policies you want to include potentially even creating even different authorization mechanisms beyond the HTTP and DNS that we just talked through.
Oh, okay. So we can pull this inside of the organization, do this internally with our own CA structure. Okay, that's pretty cool.
Do you know if there's anything in the ACME standard about post-quantum encryption, or is something that they might be thinking about?
I don't think there is, because the only keys that are used is the asymmetric keys for signing the request itself. What quantum computers are going to really screw up is key exchange protocols. Diffie-Hellman is the kind of the key exchange protocol that's used across the board, and that essentially gets defeated by quantum computers. And we're not doing a key exchange with the ACME server. So I don't think that's going to affect anything. RSA is also used for signatures, so as long as you're not using asymmetric RSA keys for your signatures. But in the end, all that's going to change is what keys you submit when you're doing the new order request, saying I'm using now MKKEM keys instead of RSA keys or instead of DSA keys and so on.
Okay. So Ed, this was a really amazing, detailed overview. I'm guessing some listeners, hopefully you weren't driving and trying to take notes at the same time, but one of those episodes where you want to be taking notes. But if folks want to find out more from you online, what you're up to, I know you have classes and courses and stuff. Tell us about all the stuff you do.
Sure, yeah. I have a website, a technical blog, practicalnetworking.net. I also have a YouTube channel by the same name. Those are probably the best ways to kind of keep up with what I'm doing. I do have some courses. I teach a course on core networking, how that works, and then another course on TLS. And it's a deep dive into how SSL works and all the cryptography associated with it, and how certificates and revocation and CSRs and OCSP and everything related to TLS includes. Essentially, it's all the stuff that I wish someone had told me about TLS before I started having to be an engineer managing TLS itself. That course is called Practical TLS. You can access it at pracnet.net/TLS or even just practicaltls.com. And it should redirect you to my course sales page. I do have a coupon code for Packet Pushers Network, and I think the code is just Packet Pushers to get $100 off that course.
Oh, nice. Appreciate that.
Yeah, and I'm actually considering adding a ACME module to the course as an additional bonus. The course is also pay once, you'd get it no matter what.
Okay, great. Yeah, just pay once and then you own the course.
Mm-hmm.
All right, that's practicaltls.com, and we'll also have that link in the show notes and use that Packet Pushers coupon to get $100 off. That's really cool. I'd appreciate that. Yeah, so thank you, Ed, for being here again, and we'll have to have you back because these are even more stuff to talk about. And of course, thanks to you for listening. If you've got a topic or a question or a comment or a correction, you can reach out at packetpushers.net/FU. We do love the follow-up. And just to let you know, Packet Protector is part of the bigger Packet Pushers podcast network, which includes more than a dozen technical podcasts for professional development. So we cover networking, security, IPv6, DevOps, the cloud, professional development. We have an industry blog, 2 weekly newsletters, our community Slack group, a YouTube channel, and an IRC group. It's all at packetpushers.net. Free, no login required. Thanks for listening.